Good morning, my friends. Today is Sunday, March 29th, and I am going to work for you the Unit 5 study guide. So Unit 5 study guide was broken into 2 days. This is the first day study guide. It's these 2 pages, solving systems of equations by graphing the first 2 questions, and then all the rest was about substitution and elimination, including the word problems. So you should have a calculator handy. You're going to want the Desmos graphing calculator definitely open for questions 1 and 2. And then for the other ones, all you need is regular calculator if you need it to be able to just do basic math. So let's start with the solve the system by graphing. So the paper gives you the graphs if you wanted to graph them by hand, but we're not going to do that because we have Desmos and it's so much easier. So to solve the system by graphing, all you do is type the 2 equations into Desmos. So let me show you. I have Desmos open here. Here is that first problem. X minus y equals -9 and 3x plus 4y equals 8. And remember that the solution is where the 2 lines intersect. It's where x and y are the same for both equations. So for example, in equation number 1, if you typed in -4 and 5, in fact, I'm going to put it down here, -4 minus 5, you see that the answer is -9, which is what it says, okay? If you, for the second one, if x is -4, 3 times -4 plus 4 times 5, you see that the answer is 8, which again is what it says. These 2 numbers, -4 and 5, are the only 2 values, x and y, that will make both of those equations true. That is what the solution means, okay? So if we go back over to the problem, the answers are -4 and 5. You would write your solution like this. Okay, for question number 2, we're going to do the same thing. Just type in the equations. Let me go back to Desmos. I have another tab open for that one. It is right here. And then you take a look at the graph where they intersect and you just tap on it. Your x value is 2 and your y value is 7. So going back over to our paper, our x value is 2 and our y value is 7. All right, that's how easy it is to solve by graphing. We wish we could just solve every problem by graphing. And honestly, if you guys were going to take the SOL test this year, which it looks like you're not, although I'm going to give it to you as an assignment for practice anyway, coming up here maybe in another week or so, you would probably be able to use any method that you wanted to. I don't think there are many problems where they specify the method because they have no way for you to actually show it. You know, on an SOL test, it's either multiple choice, pick your answer, or type in your answer. There's not a place for you to show all your work. So on that type of a standardized test, you could solve every system by graphing if you wanted to. But for these purposes, we need to make sure that you also know substitution and elimination. So let me zoom in so I have lots of space to write here. Questions 3 and 4 say to use the substitution method. So if you remember for substitution, what we need to do is look at the 2 equations, solve one of them for either x or y, whatever is easier. Take that answer and substitute it into the other problem to find out what the other variable is. Then take that solution and go back to the initial problem. When you're looking at your 2 equations, what you want to look for substitution is you want to look for an x or y value that has a coefficient of 1. This problem here, this equation would be very easy to solve for y because all I would need to do is subtract 3x on both sides. And I have y equals -3x plus 8. See, done, okay? Now, if I know that y is equal to this, I can take this now and substitute it into the first problem where it says y. So I would keep the 2x minus 7, but instead of y, I'm going to put rather -3x plus 8. Because according to the second equation, that's what y is equal to. And then I'm going to keep my equals 13. Now I'm going to solve this just like normal. Distributive property, I've got 2x plus 21x minus 56. I've got like terms right here. So I've got 23x minus 56 equals 13. I will add 56 on both sides. 23x equals 69. Divide by 23, and x is equal to 3. Okay, so now I know what x is. If I want to know what y is, I'm going to take x and I'm going to put it right here. Okay, it says that y equals negative 3x plus 8. So if I put 3 in for x, I can figure out what y is. Negative 3 times 3 plus 8. Y is negative 9 plus 8, negative 1. So if I were going to write my answer as a solution, I would put 3 comma negative 1. All right, that's how substitution works. Let's try the second problem, which is actually number 4. So remember, what we're looking for is where it's going to be easy to solve one of the equations for a single variable. And if I look at the top equation, I have x with a coefficient of 1. So all I have to do is add 3y to both sides and I'll be set. Let me do it down here where I have some space. If I add 3y on both sides, I get that x equals 3y plus 2. So since x equals 3y plus 2, I'm going to go to the second equation, and where the x is, I'm going to substitute that in. And I'm going to do it over here where I have space. 2 times 3y plus 2 minus 6y equals 6. Solve it. 6y plus 4 minus 6y equals 6. I have 6y minus 6y. Oh, that's 0y. Plus 4 equals 6. Minus 4 minus 4. Interesting. We can't divide by 0. Let's see, did I make a math error someplace? I'm going to check this. Actually, I have a suspicion about these. Hold on one second. I'm going to check this by graphing. So I'm going to pull up Desmos and I'm going to type these two equations in. X minus 3y, I have a suspicion, equals 2. And then 2x minus 6y equals 6. Aha, that's what I thought. Take a look at these two lines, guys. What can we say about them? They are parallel, which means they never cross anywhere. And what happens when you have two parallel lines? If they never cross, that means there's never an x or y value that is the same for both of them. So what we have here is a situation where we have no solution. If there is no x and y that works for both, and I see that there isn't, because right here I can't solve this equation for y. I get an undefined. You can't do 2 divided by 0. That means that there is no solution. So I think I told you guys when we were doing elimination and substitution that you should, when you're done with the problem, check yourself by graphing and see if you're right. I mean, you have that available to you. You might as well use that. All right, interesting. That was kind of fun. Let's go to problems 5 and 6. We're going to solve using elimination. Okay. So for elimination method, what I want to be able to do is add the two equations together and cancel out one of the variables. And so you may have to manipulate one of the equations in order to do that. For example, the first equation has a positive x. The second equation also has a positive x. If one of those was negative, let's say this one, if I added these equations together, they would cancel out and make a 0 pair. All right. Similarly, it's not just the x. If I look at the first equation, I have y, and the second one I have negative 3y. If this was a positive 3y, I could make a 0 pair. So what I have to do is figure out, okay, so what do I need to do in order to make that happen? And it's your choice in this situation. The first thing you have to do is make sure that your equations are lined up with the x's together, the y's together, and the constants together, okay? If they're not lined up and the equal signs are not lined up, it's not going to work. Second of all, decide which equation you want to adjust in order to be able to cancel something out. I think I'm going to take the first equation and multiply everything by 3. So if I do that, I have 3x plus 3y equals 9. The second equation I'm going to leave alone. All right, so you see now what I've done is I've created myself a 0 pair right here. So those cancel out. 3x plus x is 4x. 9 minus 29 is negative 20. I can divide by 4, and x is equal to negative 5. So I've just found my first variable. Now I can take negative 5 and I can go back to the original equations and I can put it into either one. The second equation has math. The first one doesn't. I mean, it does, but not much. So I think I'm going to use that one. So I'm going to put the negative 5 in the first equation, and all I have to do is add 5 on both sides. I'm going to make my math as easy as possible, and y is equal to 8. So the answer to this, the solution to this system is negative 5, 8. All right. Check your notes if you don't remember how to do elimination. We did lots of these problems in class. Let's slide over to number 6. So number 6, we have a problem. Take a look at the first one. I have y on the left and x on the right. The second one, I have x and y on the left. So the first thing I'm going to have to do is solve one of these equations, manipulate it so that they're both in the same form. I can either subtract 6x from the second problem, or I can add 5x in the first problem. I think I'll do that. That's going to make everything positive. I'm going to take this problem, 3y equals 26 minus 5x, and I want to put the x over on this side with the y, like this one is. So I'm going to add 5x on both sides, and you see that's going to do it. And you see in the second problem, see how x is first and y is second? So I got to make sure x is first, y is second. So I have this, okay? All I've done is solve the problem for 26 instead of for x or y. Now I'm going to take that problem and write it underneath the other one. Okay, now I have to figure out how I'm going to eliminate these variables. And this is actually, you guys, I think a terrible problem to use elimination. I would never choose elimination for this problem because it's not going to be easy to make one of the variables able to be canceled. You see that the x is 6 and 5. The y is 7 and 3. I'll have to multiply both equations to get a number that can be cancelable, which is kind of annoying. But there you go. That's what they want us to do. So I think I'm going to go with the x's, and I'm going to multiply the first equation by 5 and the second equation by negative 6. That's going to give me 30x right here and negative 30x right here. All right. But I'm going to have to do that for all, like the entire equation. So this is going to be everything times 5. This is going to be everything times negative 6. So I'm going to have to grab my calculator here. I'm just going to use my phone so I don't have to keep switching back and forth to Desmos. So 5 times 6x is 30x. 5 times 7y is 35y. And 5 times 21 is 105. On the second problem, negative 6 times 5x is negative 30x. Negative 6 times 3y is negative 18y. And 26 times negative 6, this is what I don't know in my head, negative 156. Now I can do my elimination because right there is my 0 pair. So 35 minus 18 is going to be 17, so 17y. 105 minus 156 is going to be negative 51. Divide by 17, and y is equal to, I think, 3. Yep, negative 3. Okay. Now I can take this negative 3 and I can go back to either of the original 2 problems and substitute it in. I don't really think it matters at this point. I think all these problems are kind of ugly. I'll go back to the first one. 3y minus 26 equal, or minus, I'm sorry, negative 5x. Okay, so y is negative 3, so that's going to go right here. That makes negative 9. Subtract 26 on both sides. Let me see if I can move this up a little bit. There we go. That's going to give me negative 35 on this side and negative 5x on this side, which means that x is going to be equal to positive 7. So after all that rigmarole, we find that our solution is 7 comma negative 3. So like I said, I don't think I would ever choose the elimination method for this problem. If I were allowed to choose methods, I would have just graphed it, because substitution would have been awful. And so is elimination, I think. But I mean, you know, sometimes it's good to have a fun challenge and see what you can do. All right. Now, going on to our word problems. It says define the variables and set up a system of equations, solve by substitution or elimination, clearly give your answer. So when they say define the variables, what they mean is tell what x and y are equal to. Okay, so the first sentence for number 7 says 2 times a number. I'm going to let x be the first number and y be the second number. All right, 2 times a number, that's 2x, added to another number is 25. There's my first equation. 3 times the first number minus the other number is 20. There's my second equation, excuse me. So now I need to find the numbers. I need to solve. Well, I can choose substitution or elimination. So take a minute to look at the problem, and hopefully you see what I see, which is that I have a zero pair right here already set up for me. So boom, we're going to use elimination. 2x plus 3x is 5x. 25 plus 20 is 45. And if we divide by 5 on both sides, x is equal to 9. That was easy peasy. Choose one of the original 2 problems to substitute 9 into. I'll just take the first one. So put a 9 for x. That makes 18. Subtract 18 on both sides. And y is equal to 7. So your solution is 9 comma 7. All right. Really, it said find the numbers, and we did that. X equals 9, y equals 7. All right. Let's go to the next one. At a baseball game, Henry bought 5 hot dogs and 3 bags of chips for $14.82. This is going to be our first equation. Scott bought 7 hot dogs and 6 bags of chips for $22.89. Find the cost of each hot dog and bag of chips. So we have 2 different things in the problem, hot dogs and chips. Those are going to be our 2 variables. It's important to actually write what I'm writing right now, because later on, after you get into all this math and you're writing and you're finding numbers and you have x equals and y equals, it'd be very easy to forget, wait a minute, which one was I saying was the hot dog and which one was I saying was the chips? Because sometimes they'll do like this problem and ask you for both. But sometimes they'll just ask you for one. How much did a bag of chips cost? And you need to remember which one was the hot dogs and which one was the chips. Was it X or Y? So defining your variables is, I think, a super important part of this, because what it means is writing it down like this means you don't have to hold it in your head. You don't have to remember so much as you're working. If it's right in front of you, then you can let it go out of your brain, go and do something else, and then go back and look at it to remember what you were doing. I think it makes it easier to write things down. All right, so let's talk about Henry. 5 hot dogs, that's 5x, and that's a plus. 3 bags of chips, 3y, was $14.82. All right, for Scott, 7 hot dogs and 6 bags of chips was $22.89. All right, find the cost of each hot dog and bag of chips. So substitution or elimination. I tell you what, guys, I'm going to use, when I see a problem like this where there's x and y are not don't have a coefficient of 1, I'm going to try elimination whenever I can. And the 5 and the 7 would not make things easy because I'd have to multiply both to get 35. But the 3y and the 6y, that does make things easy because I can turn a 3y into a 6y just by multiplying by 2. So what I'm going to do is I'm going to multiply the first equation not just by 2 but by -2, because remember I'm going to want that to be a -6y to cancel out with my positive 1. So now let me slide over a little bit here. Now what I have is -2 times 5x, that's -10x. -2 times 3y is -6y. And -2 times 1482, let's see, is -29.64. I'm going to copy the other problem underneath, just how it was. All right, now here's my 0 pair. And I can solve the rest of the problem. -10x plus 7x is -3x. -29.64 plus 22.89 is -675. If I divide by -3, that gives me x equals 2.25. And remember, we're talking about cost, so this is dollars. And this is a hot dog. If I want to know how much chips are, I'm going to take my 225 and go back into any of the original equations. I'll put it back in, doesn't really matter. I'll put it back in the first one just because 5 and 3 are lower than 7 and 6, and it might be easier to do math. So 5 times 225 plus 3y equals 1482. 5 times 225 is 1125. Minus 1125 on both sides. I'm going to get 3y equals, let's see, 1482, -357. And if I divide by 3 on both sides, why am I getting a negative? Oh, I'm sorry, that's positive 357. There we go. I was going to say something's not right. I can't have a negative cost for a bag of chips. Positive $1.19. All right, so if it says for each hot dog and bag of chips, this was the hot dog and this was the chips. All right. Moving on to number 9. Disney held a breakfast for parents and their children to eat with Mickey Mouse. Adult tickets cost $17.95. Children's tickets cost $12.95. Disney made $7,355 from ticket sales from a total of 500 people that attended. How many adults and how many children were at the breakfast? So we need to, first thing is we're going to define our X and Y. I'm going to let X be the adult tickets. And I'm going to let Y be the kid tickets. All right. My first, the first thing I know 2 things about the tickets. Disney made $7,355, and they had a total of 500 people that attended. So here's how you do this kind of problem. When they give you the total of like how many people or how many objects, you just make your equation simple. X plus Y equals 500. The number of adult tickets plus the number of kid tickets was 500 people. Okay. For the second equation, you use the separate costs, all 3 costs in the equation. So 1795X plus 1295Y equaled $7,355. Okay, so the first equation is just for how many. The second equation is how much, and that might help you. Okay, so I have to choose if I'm going to use substitution or elimination. I think for this one, substitution would be easy because in the first problem, I have X plus Y equals 500. It'd be very easy to solve for a variable. let's say I decided to subtract y on both sides, and I have x equals negative y plus 500. So now I can take that x and substitute it into the other equation. So 1795 times negative y plus 500 plus 1295y equals 7355. And then I'm going to have to do distributive property here. Negative 1795y multiplied, times 500 is 8,975 plus 1295y. I'm about to go into the space for the next problem, but that's okay. I have like terms right here and right here. So negative 17.95 plus 12.95 gives me negative 5y. Subtract 89.75 on both sides. $73.55 minus $89.75 gives me negative 1620. Divide by negative 5. Gives me 324. Okay. So remember what Y stands for. Y stands for kid tickets. So that was the number of children's tickets that were sold. Okay. Now, it says how many adults and how many children were at the breakfast. So we know that there were 324 kids at the breakfast. Now I can go substitute, but let's think for a second. Logically, I know there were 500 people at the whole breakfast. So if I just subtract 324, I'll get the number of adults, right? 176. There we go. Okay. The decimal ones get a little ugly. They're not really pretty to solve. Just be super careful with your decimals as you are, as you're manipulating your equations and multiplying and all that kind of stuff. All right. I'm going to erase this bottom part so that I can use this section for the last problem. And the eraser is kind of small on this thing. I don't have a way to make it bigger. I don't think I do anyway. No, it won't let me. All right. And we'll go to our last problem. All right. So Gabe has 60 coins consisting of quarters and dimes. The combined value of the coins is $9.45. How many quarters and dimes does Gabe have? So I'm going to make X quarters. And I'm going to make Y dimes. All right, so remember the first thing that they're telling you is the total. He has 60. So the number of quarters plus the number of dimes has to equal 60. The combined value is $9.45. Well, how do I know what the individual value is? Well, how much is a quarter? A quarter is 25 cents, 75. 25 cents. So 0.25 times the number of quarters plus, how much is a dime? 10 cents. 0.10 cents plus, times y, rather, equals 60. I'm sorry, not 60. Hello. $9.45, the total. It is important to put your value, your 25 and your 10, in decimal form. You can't say 25x plus 10x and then put $9.45 because that's $9.45. And a quarter is not worth $25 and a dime is not worth $10. So just be careful with that. Okay. So I think, again, that substitution would be the easiest. I'll take my x plus y equals 60. I'll just subtract y on both sides. All right, so I'm going to take this x value and plug it in right here. You could certainly solve by elimination and then come back and check and see if you get the same answer as me. You should. That would be kind of a fun challenge. All right, distributed property, negative 0.25y. A quarter of 60 is 15. And this, we have like terms, so 0.25 plus 0.10 is negative 0.15y. Let me move the subsum. Oh, it won't go but so far, will it? We're at the bottom of the page. Minus 15 on both sides. Negative 0.15y. And I hope you're noticing that we're getting pretty much positive answers for everything, because word problems are real life situations, and you can't have, you know, a negative number of quarters or a negative number of tickets or a negative number of hot dogs, right? So if you think about this carefully, you ought to be ending up with positive answers, okay? Y is 37, so that means there were 37 dimes. And again, I know that there were 60 total coins, so 60 minus 37 is 23. 23 quarters. All right, and there you go. That was Study Guide Day 1. If you have any questions about this part, leave them down below. If not, I'm going to pause the video for a second and come back with Study Guide Unit 5 Day 2. Study Guide Day 2. Let's take a look at what we've got here. It's the same thing, systems of equations, just more practice. So the first section on this page was 4 problems to solve by graphing. So let's take a look over at Desmos and see what we've got. I went ahead and put in all 4 of these systems. The first one, you see I have 2 what they look like perpendicular lines, and the intersection point is 3, negative 1. So the solution there is 3, negative 1. All right, for number 2, we have 2 intersecting lines, and if you click on where they intersect, we have negative 5, comma, negative 6. So our solution is negative 5, negative 6. For number 3, I've got intersecting lines again. If I click on the intersection point, I see that the point is 8, negative 5. So my solution is 8, negative 5. Whoops, there we go. And for the fourth one, when I put in those equations, I see a pair of parallel lines. And remember, if parallel lines, if they do not intersect, that means there is no x in common and no y in common, which means we have a situation of no solution. There we go. Okay. Moving down, we are going to solve each of these by substitution. So let me make this nice and big so I can write. All right, substitution. So if you notice, I already have, both the equations already say y equals. So I could either substitute this into the second equation or substitute this into the first equation. It's kind of my choice. So I think what I'll do is put this one right, actually that's wrong, right there where that y is. Really what's happening here, if y is equal to this and y is also equal to this, these two things are equal to each other, and that's how it turns out looking, is like that. And then I'm just going to solve. I'm going to zero pair my extra variable. Zero pair my extra constant. Divide by 3. And x is equal to negative 4. Now I can go back to either one of the original equations and put in -4. I think I'll just, actually, yeah, I think I can go to either one. So I'll go to the first one. That gives me -8 plus 3. That gives me -5. So my solution is -4, -5. Looking now at the second one. My problem here is that I have x and y together on the first equation, and they are separated by the equal sign in the second equation. So the first thing I need to do is make them look the same. I think what I'll do is I'll take the first equation and I will subtract 2x on both sides to get the y by itself. And then I'll take this and write it underneath this one. Okay, now I can decide what to do if I want to do substitution or elimination. I'm going to do substitution again because I have right here y with a coefficient of 1 is equal to this. So I'm going to take this 5x minus 27 and I'm going to substitute it right here. Wait a minute, that's wrong. I just did that completely backwards. This is y. It goes here. There we go. You guys, it's early on Sunday morning. So let's see. 5x minus 27 equals -2x plus 4. Okay. Distributive property, 15x, 3 times 27. No way. I just got a ridiculous number. There we go. -81, -2x plus 4. All right. Zero pair the extra variable first. Always zero pair your extra variable first. Please don't do the constants first. Then zero pair your constant. And I'm pretty sure the answer to this is 5, but let me make sure. Yep, it's 5. All right, so x is equal to 5. So now you go back to your original equations, these original two at the top, and figure out where we have to go back to the first equation. Since the second one is the one, actually no, the first one is the one that we changed around, right? So we need to go back into the second one to substitute. When you do substitution, you have to substitute into the opposite one. If you substitute into the same one, you get a weird answer. All right, so y is equal to -2. There's our solution. And remember, you can always check by graphing, right? So you can type those two equations in and see if the answer is 5, -2. We have 2 more substitution problems to go. These problems are a lot of work, guys, for sure. Okay, I have x plus 4y equals 19, x minus 2y equals 1. Both problems have an x with a coefficient of 1, so I can just choose which one I want to solve for. I think I'll do the second one. So I'm going to add 2y on both sides. Remember, I'm trying to get x equals something or y equals something. So x is now 2y plus 1. I'm going to take that into the first equation right there where the x is. Okay. I always put it in parentheses until I realize that I don't need them. 2y plus 4y, 6y plus 1. Subtract 1 on both sides. 18, divide by 6. Y is 3. Okay. Now, since I substituted into the first problem, I need to take this and substitute it into the second problem. The x minus 2y equals 1. Whoops, minus. There we go. X minus 6 equals 1, add 6, x equals 7. Solution 7, 3. All right. And finally, number 8. Both problems are set up the same way, which is nice. I do see a coefficient of 1 right here. Actually, it's -1, so I'm going to have to finagle this a little bit. 6x minus y equals -21. Subtract 6x, excuse me, on both sides. Negative y equals -6x minus 21. Now, I don't want negative y, I want positive y. So change the signs of all three terms. If negative y is -6x plus 21, then positive y is the opposite of that. So now that I know what y is, I'm going to go to the second equation and substitute this in right here. So 5x plus 3 times 6x plus 21, and then solve it. (17 minus 63, no idea. Oh, -46. And when you divide, x is equal to -2. All right, now you got to take that -2 and you got to put it back into the first equation. Actually, what you can do is put it right here into the equation that you just that you manipulated. It's easier. And -12 plus 21, is that 9? Yep. There we go. All right, so your solution is -2, 9. All right, substitution is definitely not, it's my least favorite of all the different types of problems for systems. I mean, obviously graphing is the best because all you do is type it in. Elimination, I think, is a little bit easier than substitution. Substitution is a lot of work, and it requires you to remember where you are in the process. And so I find that substitution to be the most complicated one. Let's go down to, we have 4 elimination problems now. So let's look at number 9. We're going to solve by elimination. So for elimination, remember we need the x in both problems to have the same coefficient but opposites, or we need the y in both problems to have the same coefficient but opposites. In order to get -3 and 7 the same, I'd have to multiply both problems to make 21, and I don't feel like doing that. But I can make the x in the first problem a -3x pretty easily just by multiplying everything by -3. So I'm going to do that. I'm going to multiply this first equation by -3. So -3x plus 9y equals positive 39. Then I'm going to put the second equation under it. And you can see your zero pair right there. So 9y plus 7y, 16y. This is going to be 64. And y is equal to 4. Okay. Now what you can do is you can take your y and go back into either of the original problems. I usually pick the one that has all the smallest numbers because just the math is easier. So I'm going to go back to the first problem. So y is 4. And that means that x is -1. There's your solution. Okay. Let's go to number 10. Number 10. All right. Let's see. X or Y. Which one is going to be easier to change? Again, we're going to have to multiply both. I can't turn 8 into 20, and I can't turn 2 into 5. But I could turn 2 and 5 both into 10. 8 and 20, I would have to turn into 40, and that would make everything else big. So let's go with 2 and 5. I'm going to multiply the first equation by 5, and that's going to give me 10x plus 40y equals 30. The second equation I'm going to multiply by negative 2, so I can get negative 10x, see there's the 0 pair, minus 40y, hey, equals negative 30. Hey, 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 look at this. Choo, choo, choo. What happens when you end up with a number equals itself? What you get is infinite solutions. If we graph this on Desmos, what we should see the first line, and then we should see the second line right on top of it, which means every x value and every y value are the same. I'm going to jot these down. 2x plus 8y equals 6. 5x plus 20y equals 15. And let's type those in and see. Let me pull this one right here. Okay, 2x plus 8y equals 6. All right. Second problem, 5x plus 20y equals 15. There it is. Do you see it? They are right on top of each other. When I had a 1 here, see I had parallel lines. And the reason is because see what the y-intercept is down there? It's like, actually, no, that's not 1. Never mind. Ignore that. But as soon as I put in the 15, you see how that snapped up there. So this is infinite solutions. These are actually two equations showing the same line. Fun. I love when something weird like that happens. All right, so there you go. That's how you recognize infinite solutions. Remember from back in the way back, it's when you have at the end of your equation a number equals itself. And it didn't have to be 0. It could have worked out being 5 equals 5 or 10 equals 10 or negative 2 equals negative 2, however it works out. Okay, let's go to number 11. And let's see, for elimination on this one, I think the easiest thing will be to multiply the first equation by negative 3. Because the negative 3 times the negative y is going to give me positive 3y. And this is going to be negative 57. And then copy the other one underneath, and you see your 0 pair right there. So negative 21x plus 2x is negative 19x. Negative 57 plus 19 is negative 38. And x equals 2. All right. Now I can take my 2 and substitute in either equation. I'm going to go to the first one. 14 minus y equals 19. Subtract 14. Negative y equals positive 5, which means positive y equals negative 5. It's the opposite. So 2 comma negative 5. Okay. And number 12. All right, for number 12, my equations are not written in the same form. I have x and y together on the first equation, but they're separated by the equal sign in the second equation. So let me change those so that they are the same. I think I'm going to, in the first equation, add y to both sides so that the x is alone. So I have 4x equals y minus 4. So let me put that under here. All right, now let me figure out what's the best way to make these two equations able for elimination. I think I'll take the second equation and multiply it now by negative 2. That'll make that y a negative 2y. So negative 8x, negative 2y plus 8. Take this second equation and write it underneath there. All right, there's the 0 pair. Negative 3x equals 9. Divide by negative 3. X equals negative 3. Choose one of the original equations to write it in. I'll go for that second one, I guess. 5x equals 2y plus 1. 5 times negative 3 equals 2y plus 1. Negative 15 equals 2y plus 1. Subtract 1. Negative 16. Let me slide this up some. Divide by 2. Y equals negative 8. All right, so I've got negative 3, negative 8 is my solution. All right, all right, all right, all right. That was interesting. Look at all this work we've done, you guys. Okay. And we've got 1, 2, 3, 4, 5 word problems, your favorites, I know. All right, let's get going here. Define your variables, set up your system, solve by substitution. I'm pretty sure this is supposed to say or elimination. So here we go. A tennis coach took his team out for lunch and bought 8 hamburgers and 5 fries for $24. The players were still hungry, so the coach bought 6 more hamburgers and 2 more fries for $16.60. Find the cost for 1 hamburger. So it's important for us to know what's hamburgers and what's fries, X or Y. I'm going to make X be hamburgers, and I'm going to make Y be fries. So my first equation is right here. 8 hamburgers and 5 fries for $24. 8x plus 5y equals 24. The second one is right here. 6 more and 2 more was $16.60. 6, 2, $16.60. All right. Solve by substitution or elimination. This is not a good substitution or elimination problem. Why don't they let us use graphing? Okay, I'm going to do elimination. And the way I'm going to do that is I'm going to multiply the first equation by negative 2 and the second equation by 5. That's going to give me negative 5 or negative 10y and positive 10y. So here I go. Negative 16x minus 10y equals negative 48. 30x plus 10y equals 1660 times 5. Let's see. 83. 0 pair right there. 14x equals 35. Divide by 14. And oh no, this is going to be a decimal, but that's okay. Because why? Because we're talking about money, right? Find the cost for 1 hamburger. So lucky me, look at that. We solve for x, and x is the hamburger, so we have our amount, but we can't say it's 2.5. A hamburger cost $2.50. Make sure you answer your question in the same unit that they're asking for, okay? All right, let's go to number 14. Jim sells hot dogs for $2.95 each and steak sandwiches for $9.95 each out of his food cart. During a busy outdoor festival, he sold a total of 985 items for $7,343.75. How many steak sandwiches did he sell? Steak sandwiches. All right. So X is going to be hot dogs. Y is going to be steak sandwiches. I mean, and you could do it in the reverse. It doesn't matter. First equation right here. Hot dogs, $2.95 each. Steak sandwiches, $9.95 each. Oh, 985 total items. So remember, you just do X plus Y equals the total items. Your second one is going to be your cost. So 2.95x plus 9.95y, 7343.75. Okay. This one I think will be easier for substitution because I have my x and y right here. I could easily say, I could subtract, let's see, I want to know the steak sandwiches, don't I? Oops, that's not what I wanted to do. Question is how many steak sandwiches, and that's y. So I'm going to solve for y. This first problem, I'm going to solve it for y. If I subtract x on both sides, y is going to be negative x plus 985, right? So if I take Oh, actually, you know what? That's backwards. I shouldn't do that. I'm thinking ahead because if I substitute y in here, then I'm going to be having x. I'll find out what x is equal to. I don't want to know what x is equal to. I want to know what y is equal to. So I was right the first time. I need to solve for x. That way, when I put this in right here, I'm going to have all x's. And x, no, I'll have all y's. I knew that was right. Okay. Sorry. Okay, so 2.95, and x is now this, negative y plus 985 plus 9.95y equals 7343.75. All right, we have to distributive property right here. I'm going to go into this section. Let's see, 2.95 times 985. These numbers are about to be ridiculous. Plus this. Okay, we've got this plus this. 995 minus 295, 7. Minus this mess. $73.43.75 minus 2905.75, 44.38. Divide by 7. Holy moly, 634. Okay, what was this problem even about? Oh, how many steak sandwiches did he sell? Okay, he sold 634 steak sandwiches. Good gravy. Gotta tell you, I'm not a huge fan of that problem. Okay, why are you doing like that? I just want to erase. I don't understand why this is doing like this. Whatever, I'm just trying to look at this weird thing, you guys. I'm trying to erase all this stuff that I wrote so that I can do this problem in this space. This is whack. Okay, is that going to be good? I think that's going to be good enough. Strange indeed. Okay. All right, let's go to number 15. 3 more to go. Whew, this is like torture. Bob bought 24 hockey tickets for $83. Adult tickets cost $5.50 and child tickets cost $2. How many child tickets did he buy? All right, so I have 2 types of tickets, adult and kid. And let's see, I know that the total cost was 83 and the total number was 24. So x plus y equals 24. Adults were $5.50, so 5.5x. Kid tickets were $2, so 2y. $83 was the total cost. Okay. Let's use elimination for this one. Let's multiply this first equation by -2. So -2x minus 2y equals -48. Second equation, just copy it underneath. 5.5x plus 2y, there's the 0 pair, equals 83. All right, goodbye to you. That was a song way back like in the 80s. I could sing it right now, but you probably wouldn't be happy with that. 3.5x equals, let's see, 48 plus 83. Okay, but now I have the song going in my head, you guys. Divide by 3.5. And x is equal to 10. That was adults, and so that he wants to know how many child tickets did we buy. Well, if I know the total was 24, 10 of them were adults, that means 14 have to be kid tickets. Okay. Moving on to number 16. Goodbye to you. Okay, I'm totally wanting to sing the song. Okay, Ethan makes $6 per hour mowing lawns and $7.50 per hour bagging groceries. Last week, he made a total of $129. The difference between the number of hours bagging groceries and the number of hours mowing lawns was 10. Interesting, we have a difference problem. How many hours did Ethan spend mowing lawns? Okay, so he's doing two things here. He's mowing lawns and he's bagging groceries. All right, $6 per hour mowing lawns. Last week he made a total of $129. So he did do the two things together. So $6 per hour mowing lawns plus $7.50 per hour bagging groceries got him $129. The difference between the number of hours bagging groceries and the number of hours mowing lawns was 10. How many hours did he spend mowing lawns? So we want to know at the end of this, we want to know what x is. So I'm going to use, I'm going to use I guess, I'm going to use elimination for this. So see how this says x plus y and this says y minus x? I'm going to take y minus x and turn it around, okay? So that would be negative x plus y. I want them to match up. Okay, so I'm going to take the bottom equation and multiply by 6. So I'm keeping the top one. And I'm going to get negative 6x, there's the 0 pair, plus 6y equals 60. Okay, so 7.5 plus 6 is 13.5. And 60 plus 129 is 189. Divide by 13.5. It's really hard to see the decimal with this little thing if you don't get it just right. Okay, y equals, let's see, 189 divided by 13.5, 14. Okay, so he spent 14 hours buying groceries. It says the difference between the number of hours bagging groceries and the number of hours mowing lawns was 10. So groceries minus lawns was 10. So this would have to be 4. So he spent 4 hours mowing lawns. Okay. Excuse me, guys. And the last problem. All right. Dustin has only nickels and quarters in his piggy bank. Nickels, quarters. He has 49 coins total. The total value is $8.85. So a nickel is 5 cents. Be careful, guys, because 5 cents is 0.05, not 0.5. That's 50 cents. Quarters are 25 cents, 0.25. All right. How many of each type of coin does he have? I guess we could... I really hate substitution. Let's do elimination. Let's multiply the first equation by negative 0.25. How about that? All right, so negative 0.25x minus 0.25y equals, let's see, 49 times 0.25, negative 12.25. Put the other equation underneath. 0.05x plus 0.25y. There's the 0 pair, 49. Okay. This is going to be negative 0.2x. This is going to be, let's see, plus 49, 36.75. Divide by, no, yeah. Wait, why is it negative? It can't be negative. Oh, silly me. This is not supposed to be a 49. This is supposed to be 8.85, the value. I put 49 in both, but the second problem with the one that has the money in it is supposed to be the value. There we go. Okay. That's going to make this negative 3.4. Okay, that's better because now when I divide by negative 0.2, I'm going to get a positive. All right. Probably the most valuable thing that you can learn as you're doing math is how to find an error, like what I just did. I made a mistake. I knew I made a mistake because the number of coins can't be negative. And I just had to go back and find where it was. So I had to sort of retrace my steps and figure out what I had done wrong. That is probably the most valuable skill you can have in any math class. All right, I'm done lecturing. X is 17, so that means he has 17 nickels. And if I know he has 49 coins total, I can just say 49 minus 17, and I know he has 32 quarters. So 17 nickels, 32 quatas. And there you go. All right, guys, that was Unit 5. Doing the study guide is making me remember how difficult this was for everybody when we were doing it. But it's okay. You just got to keep practicing it, okay? So that's it for the study guide for Unit 5. If you have any questions, send me an email. And if you need any more tutorials or practice problems, let me know. I'll be happy to put some up, okay? Bye, everybody.